Okay, so we've been working with sine and cosine graphs for the last few days. We're going to kind of wrap up our discussion about them today. So we've talked a little bit about how the amplitude can change and about how the period can change. So yesterday we were looking at kind of an equation of this type. So y equals a times sine of bx, where a represents your amplitude, and then B determines what your period is. So the period is 2 pi and then divided by B. Okay, so this equation is the same, except that you'll notice that you have this bx minus c and then the plus d. The c and the d act like the h and the k that we've seen with many of our function families, where h is your horizontal shift and k is your vertical shift. Well, with the trig equations, it's C and D, but it's the same concept. So D is a vertical shift, C is a horizontal shift. And again, just like with H, we always kind of reminded ourselves, change the sign when you pull the H out of the equation. Same thing here, change the sign on that C when you pull it out. Okay, you also might see this equation written this way: a times the sine of bx minus c and then plus d on this end. So it just depends on the equation, like what textbook or the professor is, as to which way that is written. So it might be a D in the front, might be a D on the end. Okay, how can you tell the difference? Is the C will be inside the parentheses. So if it's a horizontal shift, the C is going to be inside the parentheses. If there's no parentheses there, then it's a D and it's a vertical shift. Okay, so looking at 1 plus the sine of x. Okay, so your calculator, we can do the sine function here. Okay, so I want this one, don't want that one, don't want that one. Okay, so there's your parent function. That's your sine function. When I graph, if I'm doing them by hand, I kind of like to be able to sketch in that parent function. It helps me. So I know that your sine crosses at pi. It's going to cross at 2 pi. It starts at 0. 3 pi over 2 is going to be negative 1. So it's going to go up, come down, go back up. And there's my sine curve. I can mimic that curve over here to the left. Okay, and that's helpful for me. It might not be for you. That's fine. You don't have to graph that original parent function. Okay, well, let's look at, let me see, I'm going to kind of mimic my colors, so red. Okay, let's look at this equation then and what changes have been made. Your amplitude. Okay, so amplitude is basically the coefficient, if you have a coefficient in front of the sign. So for us, A is just 1. So the amplitude isn't going to change. It'll still be from positive 1 to negative 1. The period, well, the period comes from your B, which is your coefficient in front of your X. So for this equation, B is just 1. So the period for sine is 2 pi divided by B. Well, if that's 2 pi divided by 1, then the period is just 2 pi. Okay, so the amplitude is going to be the same. The period is going to be the same. All right, the shift. This is what's going to be different. This right here, this positive 1, that is the D. D equals 1. So then that is a vertical shift. So you're going to go up 1 unit. Okay, up 1 unit. All right, so 0. So I can do that from my parent function. So if everything else about this equation stays the same, the only thing that's happening is everything gets shifted up a unit. This 0 is going to shift up to 1. This point at 1 is going to go up to 2. This will go up to 1. This one at -1 will go up to 0. At 0 goes up to +1. So I can just bump everybody up 1 unit. And this is my sine function. Okay, so over here I put this equation in, and again, you can use your calculator, that's fine, but I do want you to kind of understand what these equations are telling you. And so there you can see it, everything's just shifted up 1 unit. Okay, let's look at number 5. Okay, so this one is a cosine equation. So we're going to start with the cosine. All right, again, the parent function. If you don't want to do the parent function, that's fine. Again, it kind of helps me. I know the parent function starts at 1. It has at pi. It is at -1. At 2 pi, it completes its period. And so my cosine looks like that. And I'm just going to do this, and really it just gives me a frame of reference. Okay, so let's see what's happening with this particular equation. And then I'm going to adjust my graph. Okay. All right, let's see. Okay, let's look for amplitude. So amplitude is my coefficient in front of my cosine. So A is 1. So amplitude is 1. My period, well, my coefficient in front of the x is just 1. So B is 1. So my period is 2 pi divided by 1, or just 2 pi. So again, it's not going to get taller. It's not going to get shorter. My period is still the same. Okay, but it will get shifted. So here, this pi, this is your C. Change the sign. C is pi. It's a positive pi, which means you're going to go right pi units. Okay, so just like on the last graph where I just took each point, like kind of the major points, your max, your mins, where you cross the x-axis, and just shifted them up 1 unit, we're going to do the same thing here, except everything's getting moved to the right pi units. So I'm actually going to start down here at the end. So this point at -2 pi and 1 gets shifted pi units. So it gets shifted all the way over to there. Okay, then this point at -3 pi over 2 and 0 is going to get shifted to here. This point down here to -1, shift that over pi units. I get shifted to there. This one gets shifted. This one up here gets shifted pi units. So you're going from 0 all the way to pi. This one down here at pi -1 will end up getting shifted to 2 pi -1. Okay, so you can see this yep. Okay, and then I can continue. I've seen what it looks like, and I can continue that shape. So again, your calculator, go here, enter, and graph. Okay, so there it is. You can do it with, your trace function and find some of those high points and low points using your trace function if you like. So whatever you find that you like is works out fine. Okay, now on Delta Math, when you are trying some of those problems and you come across, because the scale on those are kind of weird. So it looks like a period for a graph might be something like 400, okay, which looks different than what we've been doing, just kind of keeping it to like 2 pi or 4 pi. Okay, but remember that value that sits in front of the x is going to affect the period. So here's, let me kind of make something up for you so we can talk about this. All right, so if you have maybe an equation that's like the cosine, like 2 cosine of pi over 20, pi over 20x, I don't know, minus 40. Okay, something weird like that. If you're looking for the period, okay, so your period for cosine is always 2 pi divided by b. Okay, so our b is coefficient in front of the x, is this pi over 20. So to find this period, this period is going to be 2 pi divided by pi over 20. Okay, well, 2 pi divided by a fraction, we're going to go 2 pi multiplied by the reciprocal, 20 over pi. And then I can simplify, cancel pi out of the top, pi out of the bottom. And then this would be 40. Okay, so your period would end up being 40. So then you can check that with your graph and see if that matches the graph, what the graph is telling you with what your choice is for an equation. Okay, so I thought that might help a little bit. And then tomorrow in class is going to be kind of a work day, and then we will be looking at these other, graphing these other trig functions.